I'm Simon, and the purpose of this talk is basically to look at architecture versus code. So as I said in the opening session this morning, picture the scene. You pitch up to an existing team, and somebody buys you a coffee, and they take you to the whiteboard, and they draw an architecture picture. And then you get to the code base, and guess what? It's completely different. Right, so that's basically the thesis of the talk. I live in Jersey and the Channel Islands. Why is a long answer. Basically, it's a nice place to live, right? It's as simple as this. What I've been doing over the past couple of years is really helping teams understand how they can do software architecture in a lightweight, pragmatic way. But I still do write code, and I think we should drag architecture kicking and screaming back down to earth. If anyone's tried to read any of the classic architecture books, I think they're quite inaccessible. So I've put my own book together, and what I'm going to be talking about is basically some of that stuff. I'm really interested in the intersection between software architecture and code. So although the title pitches these two things head to head, it's really how we can make the two worlds converge and therefore make sense to the rest of us as software developers. Now, what's software architecture all about? Well, a lot of people think it's this big, conceptual, fluffy thing, right? And this is evidenced in a lot of the software architecture diagrams that I see out there in the world. For me, software architecture is basically about two things. It's structure. In other words, how we see the thing we're building and how it's broken up into modules, components, services, layers. And it's also about the journey of getting to that structure, right? So weaving in all the significant things that we need to think about and then communicating them to the rest of the team. And that's really what I'm focusing on here. So my real interest is how we best communicate software architecture to a team of developers. Why? So we can all build the same thing in the same way. Show of hands, who uses UML here on a regular basis, part of their job? It's like a tiny, tiny percentage. So what's everybody else doing? I've asked this question a lot from the US, all around Europe, China, and yeah, most people don't seem to use UML anymore. And this seems kind of odd because UML's, the one standard notation that we have as an industry to share our ideas, but few people use it. So I guess we're doing this. I guess we're doing no UML or something, right? Just boxes and lines. And this is a great way to screw up very, very quickly if you don't follow some simple tips. So why is UML fallen out of favor, fallen out of fashion? I guess a bunch of different reasons. It's too complex, it's too low level, it takes you down certain paths, the notation's a bit scary. There are a bunch of reasons that people throw at me for just not using UML. People often throw at this at me as well. We're agile, we do TDD instead of doing UML. Okay. Some people say, well, actually, we don't need to do architecture because we do TDD. And they think that TDD is somehow a substitute or a replacement for doing architecture. And that's not the case. For me, architecture provides boundaries in which you can do TDD inside of. So when we're communicating architectures, it's really hard to show everything on a single picture, right? Because we want to show lots of different views of the same system. And this is why those classic architecture books talk about these things, views. The logical view, the physical view, the development view, the list is endless. This is Philip Critchton's 4+1 model. There's a logical view, a development view, a process view, and a physical view. And basically, these are brought together by the use cases that you're trying to implement. Anybody use this? It's like, hands are getting fewer, 1 or 2 people. It's a nice way to think about a software system, but it's kind of confusing. So if you read Philip Critchton's original paper, this all makes perfect sense. If you read people's interpretations of Philip Critchton's paper, all the names have jiggled around, and they mean different things in different versions. And that's the thing I find most confusing about this whole views thing. Right, so I've had arguments with architects about the difference between a conceptual and a logical view of an architecture. What? Right, maybe I'm just too stupid, but they sound like the same sort of thing to me. If I'm a developer writing lines of code, is the physical view some view of the files on the file system? No, because the physical view is normally an infrastructure-related view. But what happens if our infrastructure's virtualized? Do we have like a physical virtual view or a virtual physical view? The whole thing doesn't make much sense. And this is what I often see with these different ways of representing software architecture. You know, the logical view is separated from, well, the code. Right? We're trying to force ourselves to think about the architecture of a system independently of the code. And you get this weird situation where you have your software system with views around it, and the logical views over one side and the development views over the other side. And this makes my head hurt. Right, so my kids eat ice cream too fast, and they get brain freeze. If you go onto Wikipedia and do a search for brain freeze, there are some hints and methods to prevent this. Drinking a hot drink beforehand. These are just workarounds. The easiest way to avoid brain freeze is not to eat ice cream fast. The easiest way to not get brain freeze when we're looking at these logical views and things is just to do something else. Right, so how do we do something else? Well, if I need to communicate a software system, maybe I should just go to Google and ask Google what it thinks I should do. Right, so if we go to Google, you get stuff like this. Right, if you do a search for software architecture diagram on Google, you get stuff like this. And it just goes on for page and page and page and page and page. Now, there are some UML pictures in here, but guess what? If you guys don't know UML, those options kind of go away. Block diagrams. Let's draw a block diagram of our architecture. And you get stuff like this. I can see people nodding. You've all seen these in your documents, haven't you? Enterprise architects love these things because you can do them in PowerPoint, nice gradient shading, that kind of thing. This one here is great. You know, we always talk about layering being important, so we have horizontal layers. Some are different sizes, don't know why. Some of the boxes are different widths, don't know why. Nice gradient shading, though. You know, these diagrams don't make much sense. And what I've discovered over the past few years is that teams really do struggle to communicate the design of their software. So I was running my architecture sketching workshop here on Wednesday, and I've put some diagrams at the front here. There are two piles. There's a pile that we did in the morning, kind of before guidance, and there's an after pile. And if you look through the before pile, you'll see that people do struggle. So I'm a big fan of doing architecture katas as a way to practice this stuff. And something I do very simply is just a financial risk system, which basically takes in data from one source, takes in data from another source, merges the data together, performs some calculations, and essentially produces some Excel reports, right? It's a simple batch-style system. How hard can it be? Right, but these are the sorts of pictures people draw. Right, so we have like a shopping list of stuff. Right, let's weave all these technologies in and let's just draw a picture of it. It doesn't tell us anything about the system. We get boxes and no line style pictures. Right, this is a 3-something layer or tier Microsoft solution. Why? Because it's got ASP.NET at the top. There are no people using it, so I hope we're not building this for no reason. Databases, stuff in the middle, modules, services, don't know. The functional view, right? People love drawing functional views of systems. Imagine you were getting a new house built and your building architect drew you a functional view of your house. It's basically a bunch of boxes, sleeping, eating, relaxing, right? It just doesn't tell us much. This color coding on this picture, I don't know what it means, but I'm sure the people drawing it did. Do you like this one? The central spine's kind of nice. It outlines the major steps in the process that we're trying to implement here. This green blob is like Schiphol. It's a huge airport hub, lots of connections. Stuff on the left, no idea. Different colors, shapes, lines, styles of lines. This box here says UI upside down. I don't know why. Australia. This is like Architecture 101. Doesn't tell us even we're building a risk calculator. Look, we're building a system with business logic. Excellent. I'm glad we cleared that up. This is our logical view. I've had architecture diagrams and documentation reviewed in the past by architects, and they've complained because my logical view includes technology choices. So apparently your logical view should not include technology. I see a lot of this. You've heard of POCOs, plain old C# objects, and POJOs, plain old Java objects. Homeless edition, nobody tells you about. Right? It's just a bunch of C# objects kind of floating around in cyberspace. I just want to give them a home, wrap them up in something. This is like the middle part of a bigger picture. It's a complex, asynchronous, event-driven style of architecture. You start at the top, you weave your way down through the picture. Like those storybooks you had when you were a kid. You choose your own path through the book by turning to different pages. Eventually, in the story, you die. This diagram is exactly the same. You follow different paths, you will end up in the trap. This is a lot of architecture for basically, look, adding 2 numbers up. We love over-engineering things. So when I kind of do these architecture charters, I ask people what they find challenging. And they say, well, yeah, we don't know where to start. We don't know how to express the solution. We don't know what notation we should be using. We don't know what level of detail we should be dropping down to. There are normally a whole bunch of unanswered questions. Right, so people can't draw pictures, is a summary. So how do we communicate our architectures? Well, maybe we're tackling this from the wrong perspective. So let's look at code, right? Let's start from the bottom up and see if we can weave some magic in here somewhere. When I'm drawing diagrams during the design exercise, really this is the question that I'm trying to get to the bottom of. Right, so is this what we are planning to build? Right, can I see the implementation strategy? And of course, if we're drawing pictures retrospectively, then we're trying to answer the other question, right? Is this what we actually built? Code is really, the single source of truth. And it's our representation or realization or embodiment of the architecture. So when we draw pictures, do we want to show all of that stuff? Right, so if we have a system with 2 million lines of code, do we want to draw a diagram with 2 million things on it? Not really. So this is why we drop up to the architecture views. And we're talking about abstractions here, aren't we? Right, so we're talking about abstract concepts that allow us to essentially reason about a complex or large system. We chunk stuff up so we can refer to things much more easily. And this raises a bunch of interesting questions, I think. Does the code reflect those abstractions that we think about? And this is really the whole question I started out with. You have a nice architecture picture on the wall, and you look at the code, and the code's a complete mess. But on the wall, it says we've got this nice, neat, stacked, layered architecture with lines going in one direction only. And the code's not like that. And of course, we often think in terms of components when we're drawing pictures, but actually, Java, C# doesn't have a component keyword, does it? Right, we're writing classes and interfaces and packages and namespaces and these sorts of things. So of course, there's a mismatch between our coding world and our architecture world. Who here uses a layered architecture? Now we've got loads of hands going up. Yeah, so most people adopt a layered style of architecture. What's a layered architecture? Something like this, maybe. We have presentation stuff and business stuff and data stuff, and we wire them together neatly in 6 services or components in each, and the world is a happy place. Why do we do this? A bunch of reasons: separation of concerns, substitution, mocking, testing, the list goes on. Why do we do this? People tell us it's a good thing. Right? If you go and read lots of books about software development, they'll normally start out with, here is a stereotypical application. So this picture's from one of the Introducing Spring books, and it basically says, yeah, do stuff like this. Have a presentation layer, a businessy layer, and a data access layer. What's a layer? Well, it's all about decoupling, right? So the purpose of using layers is decoupling. It's about isolating changes, making sure that changes you make here don't ripple up unnecessarily to the top. You download a bunch of tutorials and starting points. This is an empty project for Spring. This is the sort of thing you should build. Notice here, look, a domain package, or a repository package, a service package. So if this is your starting point, how do you make your application? You just plug stuff in at each of those levels. You go on to Stack Overflow, how do I structure my project? People will respond to this kind of advice. In fact, there are even tools out there which generate this style of project for you. And of course, it's exactly the same in the Microsoft world. Right, so all of the starting points for learning Spring MVC, ASP.NET MVC, they're basically starting with layered architectures. And that's fine, but What happens to a layered architecture? Does it stay nice and clean? Not so much. Sort of ends up looking like that, doesn't it? People nodding. Because this is all public, we can kind of skip around layers. I did a sketching workshop with a customer a couple of weeks ago, and they drew their diagram with some nice set of layers, and then we looked at the code, and we had to add some more arrows. And the resulting diagram kind of looked like this. We have other options. We can use hexagons and onions and all this kind of stuff. These are basically just layered architectures as well, right? So essentially, it's all about isolating your business code, decoupling, that kind of thing. Hexagons, onions, still layered architectures, right? In terms of how we organize our code, we're normally sticking these things into different projects or packages or namespaces, that kind of thing. And we can still screw up. A layer is actually bad. A layer is hurting the way that we build software. Because I do see lots of software systems that start out nice and neat, but end up as big balls of mud. Well, I don't think so. I think layers are useful. But are they architectural? The starting point for most people's architecture diagrams is we'll draw a big box representing our system, and then we'll have layers. And that's the first thing that they show about software system. Is that really interesting to us, though? You know, are the layers the structural elements, or is it the things inside the layers that are actually the structural elements that we're really interested in? So maybe the whole layers thing is just an implementation detail that we don't necessarily want to see. And of course, this reflects itself in the organization of the code base. And a lot of the ways that we describe software architectures, again, it pits the logical view of the world versus the organization of the code. And there's a gap. So we think in terms of components, layers, services, but we're not writing those things. We're writing classes in packages and layers. George Fairbanks, he was here, I think, last year or the year before. He's got a book called Just Enough Software Architecture, and in his book, he talks about this, the model code gap. He basically says when we're thinking about architecture, we have a bunch of abstract concepts. So things like modules, services, layers, etc. But these things don't exist in the code. So he's way smarter than I did, because he came up with this ages ago. In his book as well, he has a table which basically shows different ways to conceptualize or visualize or think about software architecture. And they mostly have a design model and a code model. So again, most of these ways that we think about software systems split out code from design and architecture. So maybe the trick here is to merge the code and the model. Right, who's now getting scared that I'm talking about model-driven architecture? Yeah, no. But we do want these two worlds to overlap and align. So maybe there's something in this without the whole scary generating everything from model thing. Please. George's answer is very simple. He says, well, why don't you just use an architecturally evident coding style? So in other words, when you're writing your code, you're organizing your code, why don't you make it so that the things in your code reflect your architectural concepts, your abstractions? So in other words, maybe you have a naming convention that says all of our services will be suffixed with the word service. Maybe we'll have a packaging convention that says each service or component will be in its own package. Who does this? Good. Is it useful? Is it hard work? Do you have to think about it? Good. If you're doing that, and I'm talking about diagrams and communicating software systems, why can't we just generate pictures? So if you're using an architecturally evident coding style, the diagramming tools we have available to us should be able to automatically generate those pictures for you, right? But they can't. Why? Because they don't know what a service or component is. We have to teach them about this architecturally evident coding style. And these diagramming tools basically see packages and classes. And that's whenever you run Structure 101, lattice, and append over your code base, it just shows you a mess. You have to start cleaning the pictures up. You get stuff like this. They start drawing pictures of layers, for example. You get pictures like this. It shows you lots of dependencies between things, normally between packages or between classes. Again, these are not showing services or components. Same thing over and over and over again. So maybe we're not using an appropriate language for modern software systems. So maybe we do need a language which has component or service or microservice as a first-class thing. I'm not a language guy, so I'm not going to write this, but there are some thoughts there. So how do we get these two worlds to overlap? Well, when we draw pictures, the pictures should reflect the code, and vice versa, of course. And what I really care about is a set of abstractions. So for me, a common set of abstractions is way, way more powerful and important than a common notation. And if you look at UML, UML gives you two things. It gives you a set of abstractions, right? Use case bubbles, classes, components, deployment nodes. And it gives you a set of boxes and lines notations to essentially represent those things. Now, when I see people using UML, they're normally abusing both things. So they'll have a diagram, and there'll be a class, and it won't be a class, it will be a message bus. Or they'll just use a class diagram because it's a convenient way to draw boxes and lines, and they'll scrub all the information out and just use it as boxes and lines. So therefore, maybe we should just focus on the abstractions and forget the whole notation thing. To some people, this kind of sounds foolish, but if we went to find two maps of Amsterdam, those maps would both show the rivers, the canals, the tramway, the roads, the districts, the points of interest. But they might use different colors, notational elements, shapes, symbols. But we can understand them because there's a self-describing notation here. There's a key or a legend in the bottom corner, essentially. But it's the abstractions that they show that are really important. So how do I do this? Well, I kind of put the whole logical, physical view thing aside and think about a software system as basically being made up of a number of containers. What's a container? It's something like a web server, a web application, a standalone application, an application server, a message bus, a database, a file system. Basically, it's something that you need to have running and deployed somewhere that hosts code or data. I break my software systems up into components, so I'm a big fan of chunking stuff up into components. This is a massively abused word, right? My definition of a component is very simple. It's a bunch of related stuff with a nice, clean interface. It's something you can substitute out. And because I'm mostly dealing with Java and .NET systems, these components are made up of classes, right? So these are your lowest level building blocks. Maybe these are functions if you're using functional languages, tables, views, or procedures, that kind of thing. And it turns out this is a really, really nice, simple way to think about software systems. And once you have this in your mind, you can draw pictures at each of those levels in turn. So I'll start with a context diagram, which shows my system and stuff around it. I'll then zoom into my system and basically show the containers, so the combinations of app servers, web servers, databases, and how they make my app work. I'll then maybe open up some interesting containers and look inside them, show a components view of the world and how I've decomposed my system. And then I might optionally do some class level design, optionally. Right, I don't normally do this. To show you some examples, I built a really simple content aggregator in Jersey. It's just an aggregator for people in the tech world. It lists tweets, blog posts, jobs, businesses, local people, that kind of thing. And this is an example context diagram. So this is my system here, the monkey, the system I built. It has people, actors, roles, personas at the top who use my system, and essentially my key system dependencies at the bottom. So in this case, I'm pulling data from Twitter, blogs, GitHub. If I zoom into the monkey's head and blow him up, right, we get a containers view of the world. So this basically says my tech tribe system is made up of a web application, a standalone application that updates data, content information from Twitter, blogs, GitHub, and a bunch of data sources in the middle. Right, it's nice and simple. And then if we open up the content updater thing, we get to see the components view of the world. So it's just a nice logical decomposition of the world. We've got some tech choices on here, some responsibilities. You know, it shows us quite a lot of nice things about our software. These diagrams are all available to download off the website for free, by the way. These things are like maps, aren't they? Right, so if you go onto Google Maps and do a search for Jersey, you get that view by default, which is great if you want to know what's in Jersey and how it's broken up. It's completely useless if you have no idea where Jersey is. So you have to do the, is it pinch in or pinch out, inverse pinch, I don't know, to zoom out. And eventually you get the kind of 30,000 foot view. It's the same with these diagrams. Sometimes we want the zoomed in view of the world, and sometimes we just want to step out and see the big picture. I'm not trying to create a new standard here. I just want to provide some ideas about how people should think about their software system. Right, so it's the abstractions that are really important to me. And it was interesting, when we ran the sketching workshop on Wednesday, when I asked the teams what they found challenging, one of the things I said was, we don't know how to describe our thoughts to other people. Because essentially, these are small groups of 2 or 3 people, and these people have never met before, they've never worked together before. So they're coming at this from different perspectives, they have different reference points. And they're all calling different things different names, and it's making the design process much, much harder. What this is basically doing is it's sticking the static structure of the software back in the middle, right, at different levels of abstraction. And once you understand the static structure of what you're building, it's really easy to fold in the other stuff. So you can have runtime and behavior models based upon your static structure. You can have infrastructure models and therefore deployment models that take containers onto infrastructure. Right, so for me, getting the static model right is really, really important. This all comes back to code. Right, so the static structure of a system is ultimately about the code, and that's where we as developers spend most of our lives. And basically what this admits is that, you know, actually, when we're talking about architecture and drawing pictures, we as developers are the most important stakeholders. Now, when I'm drawing pictures of my software system, I'm doing it for me as a software developer, and I'm doing it for my team. Yeah, operations people, support people, maybe there are a few other people who want to know something about what we're doing, but essentially, it's us as developers. So we have diagrams, we have code. And as I said before, the two worlds need to meet. And if they don't, well, the diagrams are pointless, aren't they? And this is what I see in a lot of organizations. They have these big, grandiose A0 sellotaped together a few times pictures of their system, and nobody looks at them. Why? Number one, they're out of date. Number two, they just can't comprehend that amount of stuff. And number three, they don't match the code. They're the creation of some grandiose architect who basically drew a bunch of conceptual fluffy boxes on a picture, and then the team ignored it and did what they want. This is a rather embarrassing question to ask me, isn't it? How did this sneak in here? So I showed you some pictures of my Tech Tribe site down to components level. Does it match the code? Well, I sort of accidentally open sourced the code base. So you guys can go and have a look at GitHub and figure this out for yourself, but I can save you the pain. The answer is yes. Get in, because I'm awesome. I practice what I preach. So yeah, you know, there's a component view of the world, and I've used a convention where each component sits in a Java package. There's a nice bunch of stuff, a nice traceability between code and diagram. Awesome. Did it start out this way? Not really, is the honest answer. I drew my Tech Tribes pictures for my book and my training course, and that's the way I'd thought about the architecture in my head. But the code didn't really look like that, so I was essentially creating a fantasy land. Why? Because I use layers. Right, I did the stereotypical Java thing of just basically building a web app with layers. So to give you an example, there's a tweet component, and basically there's a MongoDB store, and it stores tweets. And there's a simple component to get access to that store. That's it. My first implementation was this. There was a services package, a services layer, with an interface and an implementation, and there was a data access layer with an interface and an implementation. I'm using Spring. Can you tell? That's services. That's layers. That's not a tweet component, but my diagram had a tweet component on it. So really what I was doing here, I was mapping in my head the layers in the code and transposing them to a single component. But it's wrong, isn't it? The mapping isn't explicit. Two choices. Redraw the picture or change the code. I didn't want to redraw the picture because it looks complex, right? Because we have all these layers and things inside it and relationships and interactions and stuff. So I refactored the code. And now I have something like this. So all of my components sit in a package. There's a nice, clean public interface, and all of the implementation details are package protected. So they can't be nudged from the outside world. This is kind of cool. But I don't have a layered architecture anymore, is what people say. I do, it's just that my layers are inside my component. So I still have a services layer and I still have a data access layer, but they're wrapped up, they're just an implementation detail. But now you can't mock your MongoDB thing out and test it, unit test it. I can, but I have to jump through a few hoops. That annoys me, actually. I've lost the ability to unit test this thing easily. That's one of the big advantages layered architectures give you. That's why we talk about clean architecture and clean code and that kind of thing. So what, I'm just not going to do unit testing. Right, so that's the other approach here, don't do unit testing. And I don't mean don't test, I mean don't do unit testing. So with my simple example here, what benefit does unit testing actually give me? Essentially all my tweet component is doing is giving us a way to access the Mongo database. So maybe I should just do component testing through the component interface. Right, so it's another approach. There's this whole interesting thing in the industry at the moment about testing and how TDD is dead. Some of it is quite controversial, some of it you probably agree with. This is one of the original papers that sparked all of this stuff. We've come on a long way since we started doing things like mocking. Mocking out a database collection because it's slow. We've got SSDs, servers are fast. We can provision infrastructure with Ansible or Vagrant or whatever and do these things really, really quickly. So a lot of the original reasons for unit testing have kind of disappeared. I love this line in the Jim McLean paper. He basically says maybe we're not good at doing design. And DHH, the Rails guy, picked up on a lot of this stuff and said, yeah, actually, we are abusing, we've got test-induced design damage. Why? Because we're having to separate all this stuff out in order to create simple, isolated unit tests. And again, I think he's got a point. I think we're blindly walking into a bunch of these architectures and designs because we think we should, because we think it's good to unit test everything in isolation. But maybe we need to just think a bit more. So, yeah, maybe it's the significant elements that we want to test, and we don't want to blindly unit test everything. So that's why maybe thinking about your system in terms of components instead of layers opens up some different avenues for doing testing, for example. What's the point of all this, apart from I get to talk about drawing pictures and that kind of stuff? Well, essentially a good architecture enables agility, doesn't it? Right, so if we have a nice, clean structure, this provides us the ability to change it, to flex it, to enhance it, to extend it in the face of changing requirements. But of course, there are different ways to build software systems, right? So on the one hand, we have the big monolith. These things are normally easier to write, single deployment unit, often look like a big ball of mud if you open them up, especially if they evolve over years. These things can be hard to change, unless you're Etsy, and then you're awesome at it. Over here, service-based architectures, microservices. This is what Josh is going to be talking about later. Right, microservices gives you lots of agility and flexibility because instead of deploying a single thing, you're deploying lots of smaller things. And you can change them whenever you want to. You can write them in different languages. This buys you a ton of agility. But guess what? It's more complex than that. It requires orchestration. There's a bunch of other things we have to think about. It's not a free lunch. Whenever I go and stay in hotels and I get my cereals for breakfast, I go to the milk station and it's either full fat or skimmed, right? Extremes. There's never anything in the middle. There has to be something in the middle here. And again, if you really do want to create monolithic systems, maybe this is about structure. So maybe it's about injecting structure. And this is why I'm a big fan of the components thing. Right, so even with monolithic systems, I like chunking my monolithic systems up into nice, neat structures, in this case, components. The decomposition strategy that you use is really important here. Whether it's functional versus volatility-based decomposition, essentially that's how we get to a nice, neat structure. And you have to take lots and lots of stuff into account. Right? So you have to understand which bits might change and why, and try and isolate the impact of those changes. The thing I see in industry the most is that people really struggle with these concepts applied to monolithic systems. And over time, monolithic systems evolve and they do turn into big balls of mud. I've spoken about this whole component-based thing to audiences, and they're like, yeah, we don't like it. We're just going to do layers, right? We're comfortable building systems that are just layers. And they think the whole breaking your system into components is hard because you have to think about responsibilities. Yeah, guess what? It's hard. Right, but if people can't think about components in monoliths, guess what we're building? Microservices are the next big balls of mud. They're just distributed big balls of mud. So the same principles that we have to go through for decomposing our software systems and monoliths are equally as applicable to microservices. Design is key here. Design thinking is key. Architecture is key. The whole agility thing is basically, inspecting and adapting. It's about reflecting on stuff that's worked and changing what hasn't. How do we apply this to software systems? Right, if we have an existing architecture and we need to change it in the face of changing requirements, we need to see what we've got. And this is the thing people are really hard at doing. This is the whole visualizing thing. But once you understand what you have, it's really, really easy to see where you want to go to. So again, thinking about structure consciously is really important here. So my key tip here is basically have a think about how to align the architecture view of the world and the code view of the world. And by creating a really nice, clean, explicit, simple mapping, it opens up a bunch of opportunities. It makes your software systems easy to work with, easier to understand. It makes those conversations over a whiteboard much easier to have as well, because you can draw things on the whiteboard and then go, look, and this is that thing in the code base. There are no silver bullets. Right? So I'm not pitching a single approach. I'm not saying that layers are bad and you should do component-based design. I'm not saying you should do microservices. All of us are building different systems. We have different contexts, different needs. So we still do need to think. And we shouldn't blindly apply the same approaches over and over again. Layers, decoupling, unit testing. Maybe thinking about our architectures in different ways in terms of structural elements, as I said earlier, leads us to other options. And my final point is basically this. If your software system is really hard to work with, change it. And make sure you have a nice architecture view and a code view that overlap and reflect each other. Thank you very much. So the question was, when I showed you the code very quickly, there was an annotation at component with some documentation there. Do I use that to generate diagrams? The answer is not yet, but that's exactly why it's in there. So I'm working on a tool to shoot through a code base, extract components or services or microservices, and then we can automatically draw the pictures based upon relationships and dependencies. So it's a work in progress thing I'm doing. Sorry? Some of it's on GitHub already, yeah. So the annotation processor for Java stuff's on GitHub. I'm not sure if that was a question or a statement, but basically, if you go for a component-based approach, mocking's still important, and I agree. So I guess there are two things here. In my simple example of, tweet component access in Mongo, I can just go straight through, right? There's very little point in decoupling my data access object. If I wasn't accessing Mongo and I was sending email or sending a JMS message or accessing a third party, that probably still needs to be mocked. So, there's not one rule fits all. If you look at my web layer is essentially very slim MVC-style controllers orchestrating a bunch of components. How do I test those? I can actually mock out the components wholesale. So yeah, we can just apply mocking to a different level of granularity. Good point. Right, so I guess the question is how do you make sure you're thinking about your architecture in a clean way and you're not mixing up these different levels of abstraction essentially. It's all about, so the easiest way to think about this is where does the code live and how do I deploy the code separately? So if I was implementing a user story that I was deploying some code in my web server and some code in my database, so maybe there's a store procedure and a bunch of code in the web server, I would treat those things as two separate components rather than one component that has kind of two implementation sides, if you see what I mean. And again, once you do that, you can start thinking about, if you think about them as separate things, with separate interfaces, then they can be changed in different frequencies and stuff. So it's really about forcing yourself to think about stuff in isolation, I guess. If you want some good examples of what the container stuff is, there's a pile of diagrams here from the workshop which show the kind of second iteration of the pictures. These ones should be much, much clearer than these ones, and this shows you that nice kind of decomposition of a software system. So the question is, if you have an architecture, how do you make sure that you communicate that to the team effectively so that we essentially build the same thing in the same way with the same principles? And the answer is pictures, right? So this is exactly why we draw the pictures. These pictures go into enough detail that we can get a view of the implementation strategy, we can see relationships between our structural elements, and we can see technology choices. There's a low level of design inside the components, design patterns, that sort of thing. Maybe we should leave that to the developers unless we want to enforce certain principles and patterns. So that's exactly the purpose of these diagrams, it's to set a scene. This could change, right? I'm happy for the architecture to evolve over time, but let's do so in a structured way. So the question is basically how do you effectively communicate to non-technical stakeholders and what sort of questions crop up? The easiest way to do this is to use a model where you can draw different pictures at different levels of abstraction. So this is an example context picture. There's nothing technical on here. It just describes our system and how it fits in with the rest of the environment. So this is my starting point for having those non-technical conversations. If I'm talking to operations and support people, maybe I'd go down to a containers view of the world, which shows web servers, databases, app servers, but I'll stop. And the next levels are just for technical people. So again, it's by forcing yourself to think in terms of clean abstraction levels and layers that you have a story to tell from non-technical down to technical, essentially. Does that answer your question? The pinching thing, yeah. If someone can make me a web tool to do that, please, that'd be awesome. The question is, how do you take this kind of approach and communicate your architecture to operations people who want to know about deployment and infrastructure concerns, for example? So my containers picture only shows web application database file systems. It doesn't show that there's a MongoDB cluster, a web server farm, that kind of thing. So this is a separate diagram. So I'd have a deployment diagram, which basically shows how my containers are mapped onto the infrastructure. Obviously, if you've got 1,000 nodes, maybe drawing a diagram is crazy, but it's a separate view of the world. The static view of the world and then the deployment view are separate. So I guess the summary of the question is, how do I work? Is the short way to put this. And the simplest way to describe this is I do some upfront thinking. So when I'm attacking a problem, I'll draw these types of diagrams because you can do that level of decomposition very, very quickly. And then if we're doing if we want to go down the TDD route, maybe we do TDD in the components or we TDD from the outside in. So there's still lots of opportunities for evolving and using TDD or test first, test last. But that's this is the starting point for all of that stuff. And generally, design your entire application up front. I'll generally go down to this kind of detail, which puts a framework in place. So in terms of high-level components and chunking up responsibilities, it's the same thing if you're kind of doing a microservices architecture. You have to figure out what the services are. Same thing. So I have to figure out what the major components are and therefore how they interact. Cool. Well, thank you very much. Back in here at 11:30 for Josh's talk about Godzilla.